My name is Didier Rousseau. I'm from KELENN Technology, and KELENN Technology delivers Inkjet solutions, mostly different types of technologies for the inkjet, but also for some other additive manufacturing solutions. It's been a very inspiring moment these two last days. So I'd like maybe to do something to you which is back to the basics, and I believe the basics are simply developing new industrial applications. Typically, here are a few examples of applications that we develop into the company for our customers. Watermarking, inkjet printing, printing on glass with very high rub resistance, typically, printed light diffusers as well, direct-to-shape printings. I mean, the amount of new applications that can be developed with inkjet is, as you know, very huge. And I'm pretty sure that you have new applications in mind. And I think one of the few key features that you will need to remember for your new applications is, first of all, to find a lab where you can really develop the process. It could be, for example, at our place, we call that the European Digital Manufacturing Hub, where you have all sorts of equipment. I'm going to get into details later on that. You will need print engines. We provide print engines, any size, any speed, any characteristics. And you will need a number of technologies. And this afternoon, I'm going to go through a few technologies that can be useful that we have developed. They are up and running at customers. This is real stuff, not future developments. Yeah, so first of all, let's talk about vision systems. This is a technology that we've already discussed during this conference. But let's have just a quick review. So into a print systems, you have, where is the laser is here. You have print heads, of course, drive electronics, a print controller to feed data to the drive electronics, and layout editors to start designing your what you want to print, and the RIP process. So this chain is a standard chain of products, and you have vision systems, of course, to control the quality of what you're doing. Now, what does a vision system, as you've already noticed during the discussions, is missing jet detection, delta E color density measurement, stitching, alignment, integrity, database matching. All these activities here are necessary online if you want to have good quality. Now, the thing is, how would you use these results? And what we are offering here is a closed loop with the print system, so that everything is automated and the vision system is transparent. You don't see it into your application. In other words, for example, the data from the vision systems is fed back in real time with the RIP system, so that we can create some missing jet compensation from the camera, which is checking the printing. Well, missing jet compensation can be also addressed by the print controller here. And the print controller can get also information from the camera for stitching and doing a number of calibration before starting printing. What is interesting is that into the drive electronics, the alignment information is going back to the drive electronics to do full alignment. Alignment is rotation, translation, etc. regarding the printing, and making sure that the print quality is at the utmost. Surprisingly, there is also the capability to do some missing jet detection into the drive electronics. This is quite new. So the missing detections can be done by the vision system or by the drive electronics. So if this system is fully implemented, then here is an example of what's happening. Here we are printing some test charts with 2 print heads, one after the other, printing at high speed. And if the print heads are not aligned, as you can see one print head here and another one here, and all the data. So it's a big mess. So with our system, within less than 1 second, actually, everything is realigned properly and will stay aligned properly during the production. If we go back to this slide, there is an activity with the vision system, which is integrity in database matching. So if we enter more into details, that means that the camera will check every single information which is printed. And to do that, into our layout editor, for example, if you simply select a checkbox which is vision controlled, then all your data will be controlled automatically by the vision system. So the vision system will learn where are the data, what sort of data they are, and how to control this data. It can be variable data, of course, and it's mostly variable data, and this is all included inside. So in other words, this time, there is no more setup to be organized by the people into the factory for the vision system. This is taken into account automatically by the system and gives full report into the database of the customer, of what's happening on the printer in real time. Another technology which is important for you, I believe, is the ink management. I think we less and less use gravity-based systems, but that's something that has been used a lot. One sub-tank getting the ink from the main tank and addressing the ink to the print head. And we know that this is fairly simple to design, but leads to some issues regarding the temperature management of the ink, the missing jets, which are maybe coming back sometimes too often, and some low decap time or open time features related with the type of management of the ink, gravity-based. Whether this is actually active meniscus control or not, the problems are still the same here. So now, since a few, let's say half a decade or a decade, we are using mainly recirculation, where 2 sub-tanks are used to recirculate the ink into the print head here, and getting the ink, of course, from a main tank. And this is a great benefit from, great improvement from standard gravity-based. But the problem here is the complexity of the system, which cost and get sometimes some of the customers into problems for when we are talking about maintenance cost and yield, for example. What we have developed into KELENN technology is a one-tank recirculation. In other words, there is no more sub-tank. These sub-tanks are not more there. And there are mainly a benefit from the simplicity of the system, but also all sort of benefits regarding the performance of the recirculation, so the way the pressure applies on the print heads. And you can see here the stability of the pressure, which is measured over a few days. And this is the amount of variations that we can measure, 0.1 kPa over a long period of time. In other words, with such system, the pressure on both sides of the head is very precise, and as a result, and also, if you see here, the flow rate into the print head is quite high. In this example, for example, it's 120 approximately milliliter per minute. So that means high flow rate, very precise pressure control, and that means, of course, a very good ink system for your printer. There's another typical point of interest for designing inkjet printers and resolving some of the applications associated with the inkjet. This is the encoder information, the movement information. And of course, bear in mind that this movement must be measured very close to the print head. Now, the problem is that usually we use, for example, an encoder wheel, like this one, whichever. And the encoder wheel, although it's easy to set up and place into a system, in some cases there may be some problem of, for example, if you are taking the speed of a belt, so this is, the green stuff is a belt, and you see here there's a stitching of the belt. So some of the belts, very large belts, are stitched. And when the encoder wheel goes on top of this stitching, it will bump a little bit, and the information of speed will be destroyed almost compared to the performance that we need. And also, because you have some mechanical aspects here, there will be some movements of the wheel which will modify slightly the information of speed. So in other words, encoder wheels are not fully performant. And there is another way to do that we have developed. It's contactless measurement. In other words, it's a camera which is scanning the substrate or the transport of the substrate, whichever. It doesn't matter of whichever is the material. We will find the movement from the substrate or from the transport with the camera. And as you can see, we achieve approximately 1 micrometer precision of measurement at 6 meters per second, and that drives a 1200 dpi, for example, printing easily at that speed typically. And I have put here a report, a recording of what the system is delivering, because not only, of course, you can drive your electronics directly with this system, so the encoder pulse is generated by the camera, but also you can get some information on your transport belt. So for example, if we take this transport belt, so the speed is approximately 120 meters per minute, and you can see that there is a variation of speed on the transport belt here, which is measured by the system. It's about that's 40, between 60 and 40 micrometer variation here. That means that most probably the motor is not very precise, and that creates a variation of speed. And also, there is also, as you can see here, there is another vibration here. It's about 4 to 5 micrometer of vibration, and this means that there is a vibration into the chassis of the machine. So you can really understand precisely what's happening in your machine with such a device. This is the result. This is what we achieve with such a contactless encoder. This is the print quality. You can see the scale that we achieve at 240 meters per minute on corrugated at 1200 dpi. And I have placed here some pictures of the different types of. This is a belt, and you can see here a zoom into this picture of what the camera sees, and all the structure of the belt. So that's the reason for, with such a resolution, to be able to measure micrometer. And this is actually, it's a corrugated substrate, but it could be white paper, coated paper. The system will measure the speed same way. I think another key feature into your electronic system, your printing system, will be the drive electronics, and we design our own drive electronics. There are some features which are interesting, I think, such as advanced waveform control, fully scalable architecture, and we really can drive interesting waveforms to help high distance printing typically. And there are some unmatched functionalities which are interesting, I think. One of them, for example, is the fact that we can print with no gap on a pre-printed substrate, synchronized, of course, with the features of this pre-printed substrate. It's limitless in terms of size of files, speed, according to, of course, to the print head, and there are some interesting features that have been developed in cooperation with Epsons, such as the missing jet detection. So we can add missing jet detection at the drive electronics level, so that you can benefit from identification of the missing jets before you are printing. This is the key feature. Before you're printing, you know where are the missing jet. And of course, these systems are compensating for the missing jet automatically. So you don't have to do this manually. It is done automatically before you print. And so you save all the materials, because when you print, first print is correct always. I was at the beginning of the presentation introducing the European Digital Manufacturing Hub. So basically, this is to help you develop your applications. Any company can come to our site and benefit from our equipments. There are prototyping machines for understanding the principle of the process and creating the process. Then, of course, production machines, roll-to-roll, sheet-to-sheet, high volume, so you can print kilometers of paper, for example, and check that your process is stable. And of course, there are also all sort of analysis tools. There are approximately 50, I recorded 50 analysis tools into the company to help you design your product properly, and all sort of advanced development tools, for example, for web form adjustment, for ink formulation, material treatment, etc., etc. So all these are available into this platform for you. And again, this is an accelerator, because from the process of developing, or from your new process to the industrialization of this process, we can shorten the time so much that you will be surprised. That's it.
Thank you.